Everybody, welcome back to STEM Talks. Today I'm here with Dr. Raul Enriquez-Habib from the Universidad uh,
Nacional,
Nacional de
Autónoma
Autónoma de México.
de México.
In English, that would be the National Autonomous University of Mexico. He's going to tell us some about his research that he has done in his past and his career in STEM and the advice he has for young chemistry students or just STEM students in general. So, Raul, thank you for having me here. You have a really impressive background. Can you just give us a quick kind of intro background on yourself, just some of your, I guess, biggest achievements that people should know about you?
Well, I will try to, first of all, to overcome my lack of practice in English, but I will try to
That's
give
fine.
you,
It'll be more authentic that way.
yes, and I will try to answer the first question, which is, well, my background, the way I started in chemistry was when I came to this institute, and that was back in the 4th of July
Mhm.
of 1968.
Okay.
And I started, I was attracted doing my bachelor's thesis and started in organic chemistry. But when we finished our synthesis, uh, cyclohexanones,
Mm-hmm.
derivatives, I was attracted by NMR.
Mm-hmm.
We had an old A 60 megahertz baryon instrument, and I was very happy to run spectra. And as we were in our PhD studies, we were doing the samples working as technicians.
Mm-hmm.
In those years, there were no technicians, there were very few, but we as PhD students were sent, we were given the choice,
Yeah.
uh, and I chose NMR.
Great. Yeah.
And then I started in NMR. Then I finished my PhD, went to England for a postdoc to the Essex University, and I was working with, and I met several people there, very proficient in NMR.
Mm-hmm.
And I went to several meetings and had the chance to get an insight into the field of NMR that in those years was growing at a rapid pace.
Mm-hmm.
And of course, well, NMR is still growing field. It's an evergreen field.
Yeah.
Yes, and I'm still basing my research in NMR analytical tool. And then I went through studies of natural products, and then I developed some interest in making metal organic compounds. And well, when the whole process needed specific NMR, I went to Toronto University.
Mm-hmm.
And in the University of Toronto, I met with Professor Bill Reynolds,
Mm-hmm.
and we started to work together. And he was a fantastic teacher, a fantastic colleague, and of course, with him, I could make many of the publications I still have, over 50, maybe 54 publications together. And is now a professor retired, and I go and see him to Canada once in a while, and I visit him. Well, uh, one of the things that attracted me is the structure. When I was a student, it was the determination of the structure of natural products,
Mm-hmm.
which offer a very interesting universe of variety in chemical structure, in molecular structure. And I found, and I felt, and I still feel that NMR was a superb, a top technique to investigate such structures. And the modification of such structures not only led to nice, different, new chemical structures, but also when we tested these structures with another colleagues, that were doing biological essays, we found very interesting results.
Mm-hmm.
And that, of course, widened the field of interest in organic chemistry. Using NMR, testing our substances for different health problems, and this is what we are doing right now. Yeah. And the part of that of the next question that you're making, which is very interesting, how did I get interested in STEM, which goes for science, technology, engineering, and mathematics? I feel I didn't I didn't start it in particularly into any of them, because every aspect that is involved into these four letters forms part of the actual research we do. And my PhD thesis was on NMR. In fact, I was lucky to be able to be the first PhD thesis in this university using bidimensional NMR.
Wow.
And showing and demonstrating the usefulness of 2D NMR. And that was achieved thanks to the help and assistance of Professor Bill Reynolds in the University of Toronto, when we already had a number of publications together. But then it came to my mind that it would be nice to publish some of the most interesting aspects of structures of natural products and put them as a PhD thesis for 2D NMR. And I didn't realize at that time that that was the first PhD thesis using 2D NMR. But I did it. and I was lucky to receive the lessons, the teachings, the assistance, and collaborative support from Professor Bill Reynolds. Yeah.
That was a great intro, Raul. So just you already kind of touched on the science you do now, so we can skip over that one. What's something that you think people misunderstand most about science, and what can the STEM community work on to help correct that?
Well, I think that science, the professional practice that we have, can be misunderstood from bad information. If you get insight into the potential that chemistry has when we do research, you can touch aspects that go from the purely scientific, the molecular structures, the analytical chemistry, and the synthetic organic chemistry, and economic aspects, technological aspects, and social consequences of those actions. So science can, if you are well informed about what science can do for you, then it's easy to understand that scientific knowledge may serve the purpose of making the life of mankind better. I could say to my students, for example, the same way that you have, when you have a nice, very sharp knife in the kitchen that can serve to make a great salad, the same knife can do a lot of harm. So it is up to us, up to our ideological, cultural, and human side, that we make a good use of knowledge for the benefit of human life.
Yeah, that's an excellent answer. Yeah, the same, like I said, the same knife that makes your food is the one that can cause a lot of harm, and that's how science can be. If used for the wrong reasons, a great scientific invention can become a horrible tool. So kind of switching gears a little bit, what advice do you have for young students that want a career in STEM, but maybe just they're getting started?
Well, there are many.
Yeah.
There are many. Well, as I told you before our interview, uh, in the States, I've been in the States many times, in many congresses, and I learned many things from colleagues that I have in high esteem. There is no free lunch.
Yes.
If you want to make something good, you have to put effort and you have to put knowledge. And in chemistry, the beauty of our field is that the consequences of what we do can do a great deal of benefit in areas like agronomy, food industry, human health, pharmaceutical industry, energy, and environmentally speaking,
Yeah.
many consequences that our actions have. And it depends uh, on the way you are built in your studies, in the university, in the family, in the society, and all these aspects influence the consequence of our research and the purpose we imprint
Mm-hmm.
in our efforts and everyday work, trying to make it good and beneficial
Mm-hmm.
to the people. And I think that that's one of the beauty of chemistry. We have the choice in our hands, and we want to make good things with our chemistry.
Mm-hmm.
In particular, what I'm doing now, we are working in products that have to be with the molecule, the main molecule of turmeric, which is curcumin, which has many derivatives, and we have placed efforts into the synthetic organic chemistry and analogs, molecular analogs, new metal organic derivatives, and the consequences of that uh, have us right now very busy and surprised, and we are gratified by the results.
Mm-hmm.
And we find nice products, nice molecules, and we do not separate the satisfaction of seeing new molecules, good reactions, efficient way of applying analytical chemistry, and all of that is what keeps us now very happy working. And learning is a process, I would say, that never ends.
Mm-hmm.
We as teachers, we as professionals, and we as mature professors, you know, never stop learning. That's the process that they have to keep in mind.
Yeah.
When you get your PhD, that's not the end of the story.
Yeah.
Perhaps you should think about it of the beginning of a new
Story. Yeah.
stage era in your personal life that makes it even more interesting. We scientists, we chemists live with something in mind. In the religious side, you work by faith.
Mm-hmm.
In the military,
Yeah.
you work by commands.
Mm-hmm.
In politics, you work by some that might be legitimate interest.
Yeah.
But in science, we work with doubt.
Yes. Mm-hmm.
We doubt
Mm-hmm.
and we inquire all the time. Is it better? Is it good? Is it the best way? And we have to learn to live with the doubt and be brave enough to face it, the challenge of finding new things.
Mm-hmm.
And that makes our field of chemistry beautiful, mysterious, interesting, and gratifying.
That's great. So hear that, guys. You get no free lunch. You get out what you put into it, and you need to never stop learning. If you want to stop learning one day, this maybe isn't the field.
That's right.
That was a great answer. So speaking of advice, so what's something that you wish when you were a graduate student earning your PhD or even an undergrad? What's a piece of advice you wish someone told you, or that you could, if you could go back and tell your younger self, what would it be?
What is the best experiences I can mention that? I think the quest for knowledge,
Mm-hmm.
the desire of knowing more,
Yeah.
and the satisfaction of applying the little knowledge that one may have at, in those years, applying it and seeing results, and the fascination for discovery of new effects, new molecules, and learning to talk at the molecular level. It is something that, metaphorically speaking, it's something that never ends.
Yeah.
The more you learn, the less secure you might be about yourself, and in terms of what is fixed, what has not, what doesn't need any change, doesn't need improvement, doesn't, no way. There is always possibility to make it better, to make something new, to learn something that you didn't know. And this approach to science is something that lasts for your whole life.
Yeah.
And that is part of the beauty of our field. Of course, one of the things that might give you an extra bit of satisfaction is to do all this, to follow all this work, this approach, with an ethical sense and compromise to serve society and mankind. Even if it's at a little, at small scale, but just something good,
Wow.
beneficial.
That's really good. So think of the effects of what you want to study and how it can benefit mankind, even if it's just a little bit, un poquito. What's the biggest challenge that you've had as a scientist, or the biggest obstacle you've had to overcome?
The biggest challenge is it repeats. It's always present, the challenge.
Yeah.
Publishing, interpreting results, making a new publication, and making sure that your teaching is something that is imprinted with enthusiasm and knowing, getting to know that you are able to instill a view, enthusiasm in the students when you bring problems that are solved and other problems that don't have a solution yet or don't have a definitive answer. And the challenge is something that you got to learn to live with.
Mm-hmm.
There is always the challenge of knowing, of making a reaction better, of making something, a new publication, uh, being able to describe nicely what you have done, your contribution, and the challenge never ends.
Yeah.
The challenge is a part of the life of a scientist, of any scientist.
Mm-hmm.
And when you are facing a particular one, for example, to pass the exam next month, well, that's a big challenge of your life. But then once you overcome that, then another one will come, and another one, and you are going to be happy. You should never fear the challenge of making things good, better.
That's a great way to put it. So then I think this is either. No, I have a couple more. So just to base off what you've told us about your research, obviously Mexico has some excellent research labs here. Most of my audience is in the United States, maybe some European. What advice would you have to give to a student that they're in the U.S. but maybe they would like to pursue a Ph.D. here in Mexico? Can they pursue a Ph.D. here at UNAM? Is that possible?
Yes. When I started working in collaboration with Toronto University, with Illinois University, Arkansas was one of the places I still have contact with the chemistry department there. At is the UAMS, is the University of Arkansas at the Medical Center, with one of my former students in Mexico. Now he's a professor there. Cesar Compadre is his name, and we have published many things together. And with Toronto, in Canada, I made many contributions with Professor Reynolds, and I sent many Mexican students to do short research stays of 3 months, 6 months, and they got the benefit of studying NMR, with the aid of Professor Reynolds, and of course we can do many things together,
Mm-hmm.
and even better now that we have better communication.
Mm-hmm.
We have technologically advantages
Mm-hmm.
that can make us go back and forth and do scientific collaboration in education, in technology, in developing new methods, and uh, making a fluent
Mm-hmm.
interaction, uh, fluent academic interaction between our universities. I think that that depends mainly on our will
Mm-hmm.
to put our hands into common projects of common interest,
Mm-hmm.
and we are perfectly able to succeed in, well, practically anything that I've
Mm-hmm.
seen, with students from the US that can come here,
Mm-hmm.
do short stays, uh, and we can do common research, exchanging students.
Mm-hmm.
Yes, that's a process that can be done in a very nice, fine way nowadays. Much better than before.
Yeah, right, like a
Easier.
male.
Yes, yes, we have that that possibility, which is open. Many foreign students and professionals can come to Mexico, just as I've been in Europe or in the United States and Canada, in many congresses where I have lots of friends,
Mm-hmm.
lots of colleagues, and we have many. I even have a paper uh, with Professor Jim Schulery
Mm-hmm.
that we he helped us long time ago to solve a problem, and we corrected a structure that had a lot of misassignments in NMR, and with him doing when he was doing an experiment, we were able to correct a structure concretely uh, of 9 assignments in
Oh
carbon
wow.
13. And we were very happy to.
Yeah.
We went to see him, the professor Jim Schulery,
Mm-hmm.
in Palo Alto, in California,
Oh.
uh, when he was sick and he had Alzheimer, but he was still able to recognize us, and we and received us in his house by the beach very warmly,
Mm-hmm.
and things like that are small bits of parentheses of human side of our professional activity that I can recall. Of course, there are many more. Yeah.
Yeah. So I think you might have answered this a little bit previously because you have such an impressive NMR background. I love NMR. What's your favorite type of NMR? Like, do you have a favorite like isotope, like proton, carbon, fluorine, or something? And then, kind of, what drew you to NMR specific? I think you said it was the structures.
Actually, NMR is a beautiful technique
Yeah.
to begin with.
Yeah.
Yes. And you have to use it for what you need
Mm-hmm.
to solve a specific problem. For example, uh, we need the usual 1D, H1D NMR
Yeah.
experiment.
Mm-hmm.
Then you can follow into the COSI, you can uh, perform easily uh, from the menu of the libraries of the instrument nowadays. You can choose depth
Depth. Yeah.
experiments, of course, and you can go into the 2D correlation
Yeah.
experiments of carbon, hydrogen, and then the long range
Correction.
interactions.
Yeah.
But then you can go into new experiments and go into DOSI
Mm-hmm.
and go into pure shift experiments, and it depends what you need to solve.
Mm-hmm.
You can go into studies of chemical equilibrium, and you can go into dynamics, yeah, through DOSI. And this is what we're doing now. For example, we run the basic
Mm-hmm.
routine in mass spectra that provides you with a view, with
Mm-hmm.
a general overview of your molecular structure. But then you can go
Mm-hmm.
into more specific experiments. For example, we are encapsulating our molecules with cyclodextrins.
Mm-hmm.
Uh, and then you need to know if it's what's the nature of the encapsulation, and we find that the encapsulation is not such. It's a chemical uh, association in the supramolecular concept.
Yeah.
And the interaction is not so simple, just the molecule getting into the polysaccharide cyclic cyclodextrin. Things like that, for example, give you a very challenging and very surprising information uh, of new experiments that it depends. And for that, you need to get in close contact with the instruments. And you need to, the nice part of it is a good education in NMR. Like I've seen, for example, all the videos, short videos that you have placed in your site.
Yeah.
Yeah, and they're very good. They're excellent for an introduction for students, so they get interested in knowing what they can do with NMR.
Yeah.
Yeah, and this is something that you can express to your students. It gives your students the idea that the instrument should be an extension of their creativity. It's part an extension of their brain.
Yeah.
And that depends a lot on entering to the field through for example, all these brief videos that you have posted, and they are an excellent example of how you can stepwise start getting into the good applications of NMR. You don't need to do everything to every molecule. You need to choose which ones will give you the right answers. Even though so many times and very often NMR gives you redundant answers, but that's good.
You need to make sure that.
Yeah, that's just make sure about. Yeah,
that's great. And then so these last two aren't as sciencey. So who's the one scientist you would like to meet, like living or past?
Well, my teachers.
Yeah.
My teachers. The Professor Fernando Walls, who was director of this institute when I started doing my bachelor's thesis, he was a fantastic man. He was a very, the first thing we started to do when we got into the lab was, well, learn how to bend a glass tube and learn how to dry ethyl ether. Yeah, and learn how to use tools in the laboratory that will help you to do a good thesis. And he was very proficient, very generous with his knowledge, and he passed away years ago. But this is one of the names that I can recall, and I had the chance to meet in the meetings of ENC in California or ENC in Boston and other places. The Nobel Prizes that in NMR, Kurt Wittrich, Professor Ernst Anderson, and others that were, for my surprise and everyone's surprise too, they were very kind people. Very sociable people that you could talk to, and you always could learn something nice from them. And these are the people I can recall. And my friend in Canada, Bill Reynolds, that was very generous to many of my students that I sent there. Yeah,
that's great. So this last one, it's not science. For those of you that haven't picked up on it, we're in Ciudad de Mexico, or Mexico City in English, which is a great city. I love coming here. What is your favorite? So I have three questions. What's your favorite restaurant? What's your favorite bar? And which is your favorite museum here in this city?
my favorite what?
Museum.
Museum. The museum I like most is the Museum of Anthropology.
Oh, I've been to that. That's a good one.
That's superb. Yeah,
excellent museum.
Yes, and there's a museum of modern art too in Chapultepec.
Okay.
Chapultepec is a Nahuatl indigenous name for the place of the crickets. Yeah,
Okay.
yeah, and that's a great museum. Yeah,
Okay.
and of course, I could give you good advice about restaurants,
Yeah.
but I don't have
You don't have a favorite?
no. I have several
So,
several restaurants with good Italian food, with good Mexican food, with good indigenous food. Uh, this is something I always appreciate.
yeah.
And bars,
Not a bar guy?
I'm not very much into the bars,
That's
and
fine.
but I like the popular costumes. We are approaching now that we are making this interview the day of the death
Mm-hmm.
in the 1st and 2nd of November, which is a tradition in Mexico that has transcended the world. And for example, in New York, you would see, as I
Yeah.
told you, marches of lots, hundreds of people, you know, that go there to celebrate those who have parted,
Mm-hmm.
to bring them to life, to somehow, metaphorically speaking. You know?
Mm-hmm.
And this is something you shouldn't miss.
Mm-hmm.
Yeah, saying because it's a mixture of costumes and this is a
Yeah.
mixture of popular uh, beliefs. You
Yeah.
know? And it's nice to see that. And in terms of the students, well, every student in your groups and that would like to come and spend here,
Yeah.
we should make an exchange
Yeah.
of people, of students that want to come a month, 3 months,
Yeah.
and spend here doing a short, very concrete research project.
Mm-hmm.
So we would make the exchange of a student something productive,
Mm-hmm.
good, that can give the young students a good training,
Mm-hmm.
if we, in whatever we can, and that should be open, and you should conduct it.
Yeah.
Yeah,
I'll see what I can do. I got some contacts at A&M. I'll talk to them. Yeah.
and NMR apply to specific projects that we could.
Oh,
Uh,
I have one guy in mind. He works with a lot of NMR. They do the rapid injection NMR. He'd
yeah,
probably be really interested.
yeah, continuous flux NMR,
Yeah.
for example. That's and we should you should
Yeah.
conduct something that between labs
Yeah.
because when projects are too ambitious, nothing happens.
Yeah.
Yeah,
Yeah.
I mean, it just serves the purpose of making the
Time go by.
administrators take pictures and this and that, but that's useless. But if we do concrete, small projects of exchange and requests for support from administrators, and I think they're willing to support concrete actions, particularly when they produce something.
Yeah. Everyone loves getting a publication.
Yeah, we can produce publications, concrete publications, out of short periods of work.
Mm-hmm.
That's open. And it depends from
Yeah.
how we design such projects. So students,
Yeah.
our students, my students, when they finish their bachelor thesis and they see their names in a publication, they get very happy.
Mm-hmm.
They go home and show,
Parents.
look at that. I
Yeah.
mean, this is my name.
Yeah.
Here I am.
Yeah. I did.
And they get very good support and they get enthusiastic
Mm-hmm.
and I would say they get the satisfaction
Yes.
of seeing their names in papers when they are quite young.
Mm-hmm.
So that's open. You should conduct
Yeah.
it.
Definitely. Well, Raul, thank you so much for your time. Everybody, that was Dr. Raul Enriquez-Habib at Universidad Nacional Autónoma de Mexico, or the National, oh my goodness, the National Autonomous University of Mexico here in Ciudad Mexico, or Mexico City in English. Thanks, guys.